Water is one of the most important resources for life for keeping our ecosystem in balance. However, it's becoming more and more polluted because of uncontrolled human activity. One major problem caused by this pollution is eutrophication, which is happen when too many nutrients like nitrogen and phosphorus enter river and lakes. As a result, algae grow rapidly, the water turns green and cloudy. Oxygen level drop and many fish and aquatic animals die. If this continue, the entire ecosystem can collapse. To help solve this problem, a simple and natural method called a EM mud ball can be used. These mud balls are made from clay mix and beneficial microorganisms that help clean the water. They break down organic waste, reduce nitrogen and phosphorus, and restore the natural balance of the water. This method is cheap, eco-friendly, and easy to use, especially in rural areas. EM marble help reduce eutrophication and bring polluted river back to life.
Although rural areas are often seen as clean and unpolluted, water pollution in Malaysian villages has become a growing concern, especially due to eutrophication, which happens when water contains too many nutrients. There are three main causes of this problem. First, agricultural activities, where the excessive use of fertilizers and pesticides increases nutrient levels like nitrates and phosphate in waterways. Second, domestic waste from households, such as food scraps, soap, and sewage, that flows directly into rivers without treatment. This encourages algae growth and reduces oxygen in the water. And third, aquaculture activities like fish or prawn farming, which release organic waste containing ammonia, nitrogen, and phosphorus into the water. In short, while rural areas appear clean, these human activities are actually polluting water sources, showing the urgent need for eco-friendly solutions such as EM
Growth covers the water surface, blocking the sunlight for photosynthesis, and some algae produce toxins harmful human and animal. Finally, increase microbial activity hit to spread waterborne diseases such as
For this study, we have two main objectives. The first objective is to determine the effectiveness of EM marbles in improving ditch water quality. This is done by observing changes in turbidity levels over a period of 9 days. In other words, we want to see whether the water becomes clearer after the EM marbles are applied. The second objective is to measure the changes in ammonia nitrogen levels before and after the EM marble application. This helps us to understand how effective EM marbles are in reducing pollutants and improving the overall water quality. Through these two objectives, we aim to evaluate how well EM marbles work as a natural and eco-friendly solution for treating polluted water. For this part, I will explain how the EM marbles are made. First, we mix topsoil, rice hulls, bokashi, and molasses until everything is well combined. Then, we slowly add the EM solution and water little by little until the mixture can be shaped. Next, we roll the mixture into balls about the size of a tennis ball. After that, the balls are placed in a shaded area and left for about 7 to 14 days to allow microorganisms to grow and develop. Once the EM marbles are fully matured, they can be thrown into drains, ditches, rivers, or lakes to help naturally clean and improve the water quality. This simple process makes EM marbles a low-cost and eco-friendly way to treat polluted water.
You can see from the graph, turbidity level changed over the 9-day period all the three locations. At beginning, on day 3, turbidity slightly increased at all locations, especially at location 3 with 15.8% and location 1 with 29%. This happened because when EM marble were first added, they disturbed the sediment and the bottom and released fine particles, which made the water look clouded. After that, by day 6 and day 9, the turbidity started to decrease gradually, especially at location 1 where it's dropped from 39% to 18.8%, showing the biggest improvement in the water clarity. This decrease happened because the microorganisms inside the EM marble become active. They started to background the organic waste such as slush and dirt. As this process continued, the small particles settled at the bottom and the water become clearer. Overall, EM marble had reduced turbidity naturally by cleaning the water and restoring its balance throughout microbial activity. Experiment, the ammonia level was high because of the presence of organic and chemical waste in the water. However, after applying the EM marble, the amount of ammonia gradually dropped at all locations. This happened because the beneficial microorganisms inside the EM marbles, such as lactic acid bacteria, yeast, and photosynthesis bacteria, begin to break down organic waste and convert ammonia into safer compound like nitrate through natural biological process. By day 9, we can see big improvement. At location 1, decreased to 99%, location 2, 99.5%, and location 3 completely reached 100 removal. This showed that EM mark ball were very effective reducing ammonia nitrogen and improving overall
For the
water
first
quality.
objective, we focus on turbidity, which measures how cloudy or clear the water is. From the graph, we can see that on day 3, turbidity increased at all 3 locations. This happened because when the EM mark balls were first added, they disturbed the sediments and released fine particles into the water, causing it to become cloudier. However, after a few days, the turbidity started to decrease as the microorganisms inside the mark balls began breaking down organic matter. As a result, the particles settled at the bottom and the water became clearer. By day 9, turbidity had reduced by 35.4% in Pisces Lake, 29.4% in campus drain, and 26.9% in roadside ditches. This shows that EM mark balls were effective in improving water clarity over For the second objective, we focused on ammonia nitrogen, which is one of the key indicators of water pollution. At the beginning of the experiment, the ammonia levels were quite high because of the presence of organic and chemical waste in the water. However, after the application of EM mark balls, the level decreased significantly. This happened because the beneficial microorganisms inside the mark balls had break down organic waste and converted ammonia into harmless compounds through natural biological processes. By day 9, the results show a significant reduction, 99% in Pisces Lake, 99.5% in campus drain, and 98.6% in roadside ditches. These findings clearly show that EM mark balls were highly effective in removing ammonia nitrogen and improving the overall
This
water
study
quality.
focused on evaluating the effectiveness of EM mark ball in improving water quality. Environmentally, our findings show a reduction in pollution like turbidity and ammonia nitrogen, leading to cleaner and healthier aquatic ecosystem. Socially, the study promote community and student involvement in environmental care activities. Economically, it proved that EM mark ball are low cost and practically method for rural and educational setting. Educationally, this research enhanced student understanding by linking classroom knowledge with real environment application. This study is closely related to SDG 6, which is clean water and sanitation, which highlight the importance of clean water and sustainable sanitation. By using mark ball as a simple, low-cost and eco-friendly water treatment method, the study helped reduce pollution and improve the water quality in discharge and lake. It also support SDG 12, which is reversible consumption and production, as mark ball use natural materials like clay as a medium to absorb pollution, molasses as food for beneficial microorganisms, and water from the mark ball mixture. All these methods are nutritious and environmental friendly. Finally, the study contribute to SDG 14 life below water by protecting aquatic systems such as river and lakes. Treating water with mark ball reduce toxin and excess nutrient, preventing eutrophication and safeguarding aquatic life. This study meet the expectation for our main target group, especially the local community around Parit Baru and Polytechnic Sultan Idris Shah, by helping to improve water quality and the surrounding environment. For education institution, it provide practical learning opportunities for students, connecting classroom theory with real environment application. In addition, this study support community program and environmental NGO through activities such as EM mark ball making and natural eco-friendly water treatment effort.
Why and how turbidity happens? EM mark balls contain beneficial microorganisms such as lactic and acid bacteria yeast and photosynthetic bacteria. These microbes help decompose organic matter like decaying leaves, food waste, and sludge in the water. Decomposition and sedimentation, as the organic materials are broken down, fine suspended solid particles become heavier and settle to the bottom, making the water clearer. For reduction of suspended solid, the microbes produce enzymes and organic acids that bind and clump small particles, speeding up sedimentation. And for ecosystem balance, the microorganism stabilize the water's biological condition, reduce algae growth and unpleasant odors, which further improves water quality. So why and how ammonia nitrogen happens? Nitrification process. Beneficial bacteria such as Nitrosomonas and Nitrobacter inside the EM mark balls convert ammonia into nitrite and then into nitrate, which is much less harmful to aquatic life. Second, organic matter breakdown. EM microorganism decompose organic waste, reducing the source of ammonia production. Next is biological competition. The beneficial microbes outcompete harmful bacteria that normally produce ammonia, preventing further accumulation. And next is improved oxygen levels. EM activity increases dissolved oxygen in the water, allowing oxidation process to work more efficiently in converting ammonia.